Guys, welcome to the channel. This is Waga. We're going to do another Leetcode question, and the question in question is number 100, same tree, which is pretty straightforward. We're going to use recursion to solve it. So you're given two binary trees, and you're supposed to check whether they're the same. Like in this case, 1, 2, and 3. The first P is equal to Q, and in this case, we notice that the 2 is on the left side and this side the 2 is on the right side, so they're not equal. And when we come to example 3, we find that the 1 and the 2 are not in the same place, right? So we should get false in this case. So this is pretty straightforward. What we could do here is we could come here and create a variable and say same is going to be true, like so, and then we can create a function which is going to check whether they're the same, and we're going to recursively call it. We could say check same, and what it takes is it takes P and Q, and we want to modify the same up here, right? So we're going to use non-local, so we say none or local and the same. We want to modify the same in the first def, not the one that is in the locally scoped, right? And the next thing we need to do is we need to we could write an if statement that checks whether or not we have a P and a Q, right? So we say if not, or if you ever get to a place where we still have nodes in P but not in Q, we know that it's not the same, right? So we say if not P or not Q or the same, we have checked and the same has already been turned into false, right? We don't need to continue running this recursion, right? So this is an optimization to make it more efficient, right? So we say and or not same, we just need to return, right? And that's what we do. It's to be and, not or, so we say and not Q. We come here and the next thing we do, we check elif, the elif, and we say elif not P or not Q, like so, right? And if there isn't a P or a Q, we just return. We say this. We change the same into false, and after we change the same into false, what we do next is just return, right? And the next thing we need to do is we need to check whether the values of the two are the same, right? We say elif P dot val is not equal to Q dot val. If the values of the two are not the same, well, all we need to do is just set the same to false, right? We set the same to false, and afterwards we just do the same thing of returning, like so, right? And afterwards, the next thing we do is we can call this function that we just created recursively on the left and right side, right? So we could say check underscore same, and this is just going to be P dot left and Q dot left, and we also call it on the right side, right? So we could just say check underscore same, and this is going to be Q dot right and the P dot right, like so, right? And after that, we could call the function on the nodes we're given, the function that we created. So we say check underscore same, and we want to call it on the P and the Q, like so. And what we want to do at the end of all this is just to return same, like so. Let's run it, and it's accepted. And afterwards we submit it and give it a second, and it's accepted. And the time complexity is going to be pretty straightforward. It's going to be O of P plus Q, where P and Q are the number of nodes in the inputs, the various trees that have been passed in, and we're not creating any structures, so the space complexity is going to be O of 1. Pretty straightforward. Thank you for watching. Subscribe to the channel, and I'll see you in the next video.